Please don't forget to like, subscribe, and comment. Thank you so much.
Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +2348085095144 to learn more and get started today.
Okay, you know this is about kinematics. You've heard of the word kinematics.
Yeah.
Now, it's a branch of mechanics that is concerned with motion without really bothering about the force that produces the motions, just the motion, kinematics. Now, when we are now involving the forces, we talk about kinetics, you know, some dynamics. So, and you know the equations, the kinematic equations, or what you call suvat. Can we list them once again? You said, am I right? Just so that you can recall.
Sorry. Suvat equations.
Suvat equations, yes.
S. Wait, let me just write. I know S is equals to VT plus half AT squared.
Okay. I will write that down. I will call it number 4. S equal to UT plus half AT squared. Yeah, any other one you can remember?
I don't know. I don't know how they arrange it, but I know acceleration.
No, it's not. The arrangement is not important at all. Just anyone. Why I wrote it last is because it's more complicated than the other ones.
Oh yeah. A is equals to V minus U over T.
Or simply V equal to U plus AT.
Yeah.
And there's also V squared equal to U squared plus 2S, isn't it?
Yeah, V squared equals to U squared plus 2S. And speed equals to distance over time.
Okay. So, alright. V squared equal to U squared plus 2AS, and this speed equal distance over time, or S equal to U plus V over 2T. Now, I want to say something about what you just said. U plus V divided by 2. Before that time, I'm coming. I will explain to you why this has to be this way. If you don't write it this way, you may be making a mistake. Times T. Okay, so the 4 equations, suvat equations, S equal to U plus V over T times T, V squared, V equal to U plus AT, V squared equal to U squared plus 2AS, S equal to UT plus half AT squared. Now, you know, the first one is what we know from the speed triangle. You know, speed is equal to distance over time. You know what I'm talking about?
Yeah.
Alright, so U of V is equal to distance over time. U of V is equal to distance over time, S over T. I need to emphasize this just a moment. U of V is equal to distance over time. make the triangle a bit bigger so I can accommodate this thing I'm trying to draw. So, velocity, which could be initial or final, is equal to distance over time. And so distance is equal to what? From this formula triangle, if you can see what I'm circling.
Yeah.
Distance is equal to what? So go ahead and tell me what distance S should be from this formula triangle.
Oh. Speed times time.
Okay, speed times time. Now, you say speed times time if it is a motion with constant speed. In other words, just a single speed. How about if it is accelerating? In other words, if it starts with an initial speed and then changes to another speed, from initial speed to final speed. From an initial speed to a final speed. You can't just say distance is equal to one particular speed times time. You have to use the average speed. In fact, this is the average speed, what I'm circling at. Can you see that?
Yeah.
If you need to find an average of two different data, you add the data and divide by 2. So this one in bracket is the average speed. So what I'm saying is distance is equal to average speed times time. U plus V over 2 is average speed, and you use this especially when the speed is not constant, when you have initial speed and you have final speed. If speed was constant, we would have just said distance equal to that constant speed times time. But if speed is not constant, the case you have in most motions, you have to use this formula, which is distance is equal to average speed times time. Alright, so that's basically it. The way we do this, when you see a question, you look at the quantities given, and then you look at the particular equation that contains those quantities together with what you're looking for. We have 4 equations. 1, 2, 3, 4. Now let's look at, just for an introduction. A particle is moving in a straight line with a constant acceleration of 3 meters per second squared. At a time t0, the velocity of the particle is 2 meters per second. Find the velocity of the particle at time t equal to 6 seconds. So which one can we use based on the information given? So for each one, you tell me what it is. This 2 meters per second is what? Is it U, V, S, T, or A?
U.
U, that's the initial speed. So that's U. We have U here. And of course, from T0 to T6, the time is 6 seconds. So this is T, which is already there. And then we have the acceleration A, and we are asked to find the final velocity V. So I think this one is simple enough. Which formula can we use? Equation 2.
Yeah.
Equation 2 directly, which is equal to U plus AT. Alright, so that's simple enough. We don't need to bother ourselves with that. We simply use V equal to U plus AT and substitute those values. Okay, I won't look at all. So, but I will just, for instance, number 2, a car is approaching a traffic light. Or a car is approaching traffic lights. The car is traveling with a velocity of 10 meters per second. The driver applies the brakes to the car, and the car comes to rest with constant deceleration of 16 meters. Modeling the car as a particle, find the deceleration of the car. Okay, what are the information given here?
A is given.
A is given. Is A given? That's what we're looking for.
Oh, sorry. Yeah, we need A. So A is in the equation. Then we have
time.
We have no.
We
We
have
have T.
what?
We have time. We have final. We have initial.
What is the initial?
Um, 10,
Initial is 10. What's final?
0.
Final is 0 because it comes to rest. So final is 0. So V U is 0 here. Okay. Alright, so that's that. We'd most likely get a negative value. And of course, you know that negative acceleration is deceleration, isn't it?
Yeah.
So all I just need you to, because those things are necessary to be reflected in your work. If, for instance, you got A equal to minus 2, just for illustration, assuming you got your answer as A equal to minus 2 meter per second squared, it means the deceleration is actually 2 meter per second squared, isn't it?
Yeah.
You don't have to include the minus again for the deceleration. So deceleration is just the modulus, which is 2 meter per second squared. You know what I mean by modulus? Absolute value. Have you got into that in math?
Yeah. No.
Absolute values are quantities without the negative. Anyways, what I'm saying is if acceleration is found as minus 2 meter per second squared, the deceleration is simply 2 meter per second squared without the minus. So please, I will skip some of these so that we look at the ones that are more challenging. So can we look at a few? We just do some jumping.
Okay.
A car accelerates uniformly while traveling on a straight, and the car passes two signposts 360 meters apart. I think that's the distance given. S.
Yeah.
S is given. The car takes 15 seconds. Time is given. It has a velocity of this. Find the velocity of the car at the first signpost. Okay. When passing the second, so this will be the final velocity U. So we need to look for the initial velocity V. Do you think there's a particular equation we can quickly use here? Time is given, distance is given, initial velocity is given. Yeah, time is given, distance is given, initial velocity is given. It's the final velocity we're looking for. I think equation 1 is just suitable for it.
Yeah.
Okay. Please, a quick run down. A cyclist is moving along a straight path, A to B with constant velocity this. A velocity at A is this. Take this, fine, blah blah blah. Okay, you should do that. A particle is moving along a straight with a constant acceleration from point A to point B, where AB is this. The particle takes 6 seconds to move. The velocity of A, you should do that. I'm moving forward. Okay, let's do number 7. You know, if they are not giving an SI unit, you need to do the conversions first. That's a hint given here. Can you see number 7?
Yeah.
Okay, train is traveling on a straight track and is slowing down with a constant deceleration of 0.6 meters per second. The train passes one signal pole with speed of 72 kilometers per hour, and second signal 25 seconds later. Find the velocity in kilometers per hour of the train as it passes the second signal and the distance between the signals. So since we are asked to find the speed in kilometers per hour, you don't need to convert this. this one that is already given in kilometer per hour, you can leave it. But the time should be in hour. Do you understand?
Yeah.
Or you may want to convert. Okay, this is given in, the acceleration is given in meter per second. So you need to change everything to SI unit, please. Because the acceleration is given in meter per second. All should be changed to SI unit. In fact, is the safest thing to do. Change everything to SI unit. Meter per second square, meter second. If they need you to convert after your answer, you can do that. Okay. So let's see what we have. We are making progress. It's getting exciting now. We've left all those cheap questions. Let's see what we have for this question number 7. Are you ready? You're not on the Jamboard again. Are you still there?
Yes, I am.
Okay. Let's see. Deceleration is given, which is A. So we have A. Which of course will be minus 0.6. Yeah, number 7. The train passes one signal with the speed of this. So this is the initial speed, U. And of course this is time. So we have to find the final speed here. And then we find S here. So which equation? We need to do the conversion first. Convert this to SI unit. Because the acceleration is given in meter per second. Are you getting what I'm saying?
Yeah.
Let's convert 72 kilometer per hour to SI unit. Let me do this so that we can use this space to do our work.
That must be 1,000 over.
Yeah. 72.
Yeah, 1,000 over 3,600.
Yeah, 72 times 1,000 over 3,600. Because you need to convert 72 kilometer to meter, you multiply by 1,000. Then you convert hour to seconds, you multiply by 3,600. And this is per, which means over. Alright, so now it is in meter per second. Do you have your calculator there?
No.
Anyway, this is a simple math. This will be 2,
20.
1, 2. It will be easy to strike out. This strikes out this, these two strike out. So you have 720 over 36. That will be, I think, 200 or 20. Are you working it out? Because I want us to.
Yeah. I got 20.
Okay, 20. Okay, so 20 meter per second. So that's the speed, initial speed. So we can find the final speed. For this one, what do we do? The first question, V, U, 80 are all given. So we use U plus 80. After that, we convert to kilometer per hour. How do you convert meter per second to kilometer per hour?
You just did the same. You multiply by 3,600.
No, I said because the answer you're going to get will be in meter per second. Assuming we got 180 meter per second, can we change it to kilometer per hour?
That's what I said. Multiply by 3,600 and divide by 1,000.
Okay, the reverse. Okay. The reverse. Okay. All right. Okay, I thought I had something else. Because what I was thinking is you could just do 108 over 1,000 to change it to kilometer, and then divided by, because that's per means divided by then 1 second, which is, of course, that will eventually give you that 1 second over 3,600. So you are right, because eventually it will be 108 times 2,600 over 1,000. All right. So assuming we got this, please can we move forward? The distance, you know the formula you can apply. Let's look for something. Let's see this E. Let's see this E. Are you ready for it?
Okay.
Number 9. A skier traveling in a straight line up a hill experiences a constant deceleration. At the bottom of the hill, the skier has a velocity of 60 meters per second. After moving up the hill for 40 seconds, he comes to rest. Find the direction of the skier. Okay. Anyway, that one is too simplistic. Initial speed is given, time is given, it comes to rest, so final speed is also given, which is 0. You know that now?
Yeah.
So deceleration is A. We're asked to find V, U, T, and A. You just apply the simple formula, and then the distance. You can use any of the V squared equal to U squared plus 2AS. And you make S a the formula. This second one is asking us for S. And if you use V squared equal to U squared plus 2AS, you can even use S equal to UT plus half AT squared. You know. Make S a formula simply S equal to UT plus half AT squared. Okay. Please let's move to another page. We can get something more challenging there. I'm on the next page. I think these are exam style questions.
Yeah.
So this is number 10. Please just read it and tell me what to do. Let's start with that.
A particle moving in a straight line with constant acceleration is line of this line. Particle moves from A to B. So the velocity of the particle at A is 20 meters per second. B and the velocity of the particle at B is 7 meters per second. Particle takes 20 meters over A to B. Find the acceleration. 7 minus 2 over 20. The velocity of the particle at A is 11 meters per second. Find the time taken for the particle to move from E to C. It's equals to, we don't know this one.
Alright, so you said this one is 7 minus 2 over 20. That's final minus initial over time 20 seconds. So 7 minus 2 over 20 to get the acceleration. The velocity of the particle is 11. C is 11 meters per second. Find the time taken for the particle to move from B to C. So now B becomes the initial now, and C becomes final. Do you understand?
Acceleration is same. No.
Constant acceleration, so acceleration is the same.
Okay, so you use your answer from that.
Yes. Yes.
And then the distance from A to C.
You just apply any of the formulas.
Yeah, any of them.
Alright, that's very good. So A is simply P minus 2 over T for this first one, and this second one we just apply the same. Since V is given, U is known, acceleration is the same for this B. Okay, all right, I think that should be fine. Which one can we, let's see this one. I'm trying to see anyone that might that can really be a bit challenging. A cyclist travels with a constant acceleration of x meter per second square in a straight line from rest to 5 meters in 26. She then decelerates for find the value of x. Can you try this? This number 12. You know what is written here? You know area under the graph is, for a velocity time graph, area under the graph gives you the distance, isn't it?
Yeah.
So if you also sketch the area under the graph and calculate if you sketch the velocity against time graph and calculate the area under the graph, you can also get the distance, like they rightly said. So that's also correct.
I know, just find the value of x by doing.
Yeah, that's easier if you ask me. What I'm just saying is a graph of velocity against time. The area is the distance. Okay, so how did you say you want to do it?
I know, just do 5 over 20.
All right. A cyclist, a constant acceleration in a straight line from rest to 5 meters per second. From rest, that's initial velocity is 0, final velocity is 5. In 20, she then decelerates from to rest with constant deceleration of this. Find the value of x. Okay. She then decelerates from this to rest without constant deceleration of this. No. Okay. All right. Let me see. A cyclist travels with constant acceleration of x meters per second in a straight line. I think you need to find x.
That was what I just said.
Oh, okay. Yeah. When you find x, you can easily. That's.
And I said it's like finding x plus 5 over 20.
Yes, please. That's it. Because a is equal to v minus u over t. V is 5 minus 0, which is u over 20. So just 5 over 20 for x. That's to find x. And then the value of x, you have it for the second part of the motion, and just do your s equal to ut plus or whatever equation.
Yeah.
And let me see, is there anyone we can, will this one be what our time, or we move on to something else?
I don't know.
A particle is moving with a constant acceleration in a straight line. It passes through 3 points A, B, C with velocities 20, 30, 45 respectively. The time taken to move from A to B is t. Okay, I think this will require some thinking. So let's do it. Let's do 13.
Okay.
The particle is moving with constant acceleration in a straight line. It passes through 3 points A, B, and C with velocities 20, 30, 45. The time taken to move from A to B is t1, and the time taken to move from B to C is t2. Okay. What do you think you should do? Let's go.
Wait, what? Are we doing this?
Yeah, I'm asking you to tell me what you should do here. a practice question for you.
A particle is moving with constant acceleration in straight line. A practice through 3 points A, B, C, D. A, B, and C, right? It's the last thing.
Yeah.
That's respectfully.
Yes,
Time to get from A to B is
T1. Always remember when it says constant acceleration, it's the same acceleration all through.
Yeah. The time taken to, yeah. So that's T1 over T2 over 2 over 3. So don't you just find T1?
Yeah. How do you find T1? Can we just work motion between A and B?
That's constant acceleration, right?
Mm-hmm. So since it's a constant acceleration, we can say that acceleration A is equal to, between A and B, motion between A and B, between point A and B, for motion between point A and B, that constant acceleration is equal to 30 minus 20, right?
Yeah, over T.
Over T. Okay, between B and C, that same constant acceleration is what? Same value, 40 minus 30 over T2. This one is T1, is it not?
Yeah.
And since it's a constant acceleration, A is equal to A, so this is equal to this, okay?
Yeah.
No, sorry, this is 45. 45 minus 30 is what I should have written. This is 45. Alright, so this gives 10 over T1, right? Why this one gives 15 over T2, sorry. And since both of them are the same acceleration, 10 over T1 is equal to 15 over T2. Did you get that?
Yeah.
So you just simplify. 10 over T1 is equal to 15 over T2 because all of them are A, same as constant acceleration. Make T1 over T2 the solve the formula. First of all, you're going to have 15 T1 is equal to 10 T2. So T1 over T2 will give you T1 over T2 will give you 10 over 15, which is 2 over 3. Proven. You get that?
Yeah.
Now it says find the distance between A and B. Find the distance between A and B.
So since found A1 to 10 and C to 15. Can you not just use like an equation?
No, see, there's a time given you. There's an additional information. Given also that the total time taken for the particle to move from A to C is 50 seconds.
Okay.
There's an additional information. The total time taken for the particle to move from A to C is 50 seconds. So what equation can you derive from here?
That is T1 plus T2
is equal to just T1 plus T2.
T1 plus T2 is equal to 15.
Beautiful. So we can just obtain another equation. T1 plus T2 is equal to 50. So you can make T1, this is the formula. T1 is equal to 50 minus T2. And from here, T1 over T2 is 2 over 3. So we could have gotten this. I don't know what we're doing. May not even be necessary, but it's good to, because you might want to substitute. From here, T1 is equal to 2 T2 over 3. From here, T1 is equal to 2 T2 over 3. It may not be necessary. Okay, so find the distance between A and B. So it's actually T2. We should have made the side of formula. Let me make T2. T2 is, since it's between A and B, T2 is equal to 3T1 over 2. 3T1 over 2. I'm just making T2 set the formula from here. From the information given. T1 over T2 is equal to 2 over 3. So T2 should be 3T1 over 2, which you can substitute here. Are you still with me?
Yeah.
So I said T2 is 3T1 over 2, so substitute T2 here. What do we have? So T1 will actually be equal to 50 minus 3T2, 3T1 over 2. The equation has solved itself. You can get that time. What are we doing? I'm looking for time again that we've already found. Oh, this is not necessary. We've already found the time. I thought we hadn't. Oh, sorry. Which question am I solving, by the way? Oh, okay. So that's fine. What I'm doing is still necessary to find T1. Please, I need to carry you along. Sorry, I mistakenly jumped into something else and I got some things mixed up. But what I'm doing is still very necessary. We need to find that time. Now look at the question. It says what? Read the question we are solving. B.
Find the distance between
A and B. The distance between A and B. We need the time between A and B so that we can find that or other information. The time between A and B. Did you get that?
What do you mean already find T1?
No, we didn't find T1. No. We didn't find the value. What we are given is T1 over T2 equal to 2 over 3. We never found its value in particular. We just found a relationship connecting them. And also what we are given is A to C, which is the total time. Because A to B is T1. B to C is T2. So A straight to C is T1 plus T2, which is 50. Now I decided to make T1 subject of formula because the question is the distance between A and B where you have T1. You're not on the Jamboard again?
Yeah.
Alright, so let's solve this equation to get T1.
Okay.
So solving this, we now have 2T1 is equal to 100 minus 3T1. So this will give us 5T1 is equal to 100. That gives us T1 is equal to 100 over 5, which is 20. I'm just solving this equation. I multiply all by 2. You can solve it in any other way you know. You know, that's mass now, is it not?
Yeah.
I multiplied everything by 2. Whichever way you know how to solve it, all you need is to help us to find T1. Since 2 is the only LCM, I multiply all through by the LCM. So this gives 2t1 equals 100 minus 3t1 because 2 cancels out 2. Anyways, eventually t1 is 20 seconds. Since we are looking for the distance between A and B, this is the kind of question you will get in exam. That's a proper exam question. Pass. I think it's even from the past question. That's why they say /P or something. Alright, so that's what I was actually looking for. Those ones were just to prepare us for the main thing. So we found T1. We can go ahead and find the distance. The question says find the distance. Are you there?
Yeah.
So we can find the distance. Which equation can you use? And what do you have given? Very quickly.
You have time.
We've found the time, which is 20 seconds.
Yeah.
20 seconds. And we're giving initial and final velocities. For A to B, initial velocity is 20, final is 30, okay? Is it not?
Wait, sir.
Yeah, U is 20.
Messiah,
Yes.
if you knew, like, I thought, like, if you knew the relationship between T1 and T2 was 2/3,
Mm-hmm.
why did you do like 2:3?
And just find T1 without all this process. Yes, it could have been done because the total of it is 50. We would have still gotten the same answer. I agree with you. We could have just used that because T1 ratio T2 is 2:3, is it not?
Yeah.
And they are sharing 50. They are sharing the total of 50. So we would have gotten T1 by saying 2/5 times 50. We would have still given us the same answer. Am I right?
Yeah, but
Cool.
that's what I'm saying.
Beautiful. Because 2 ratio for T1 over sum of ratio 5 times 50 what they are sharing. So the method I use is just longer. So this is what could have been done alternatively to get T2 or to get T1. So alternatively we would have gotten T1 here. T1 would have just been this. Alright, so that's that. V is given, U is given as 20 meters per second, V is given as 30 meters per second. We can just apply V squared equal to U squared plus 2AS to get the distance. V squared is equal to U squared plus. Is the acceleration given? Is the question?
Yeah.
Are you sure?
Oh no, it isn't.
It's not given. No,
But you could-
we can use S equal to U plus, no, S equal to U plus half a T. S equal to U plus V over T. S equal to U plus V over 2 times T. We can use that to find the distance. Do you understand?
Yeah.
S equal to U plus V over 2 then times T. We use that to find that. Okay, I think that should be it. Please don't forget to like, subscribe, and comment. Thank you so much.
Welcome to Like Learning School, your premier online education platform. At Like Learning School, we are dedicated to helping students and learners unlock their full potential, providing them with the foundation, support, and guidance they need for academic excellence. Our platform caters to two main target audiences. Firstly, we work with school children of all ages, offering academic follow-up and accountability partnerships. Our seasoned tutors provide personalized attention to ensure students stay on track and reach their goals. Secondly, we support students and learners who are preparing for internal, external, entrance, or professional examinations. We offer comprehensive and well-structured support to help them achieve outstanding performance in their exams. Our robust virtual courses are designed to keep students engaged and motivated. With interactive videos showcasing our teaching sessions, students actively participate in the learning process, making education enjoyable and effective. But that's not all. We believe in personalized education. Our students have access to personalized tutorial sessions, whether online, physical, or hybrid, tailored to their unique learning needs. Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +234 808 509 5144 to learn more and get started today.